3, 2, 1, 0. Ignition and liftoff. Godspeed, Endeavour and Crew 2.
Copy, 1 Alpha.
Space launches are cool, but rockets use up all of their fuel pretty quickly. The first stage commonly fires for less than 10 minutes. Once all the rocket stages have cut out, a spacecraft can use electric thrusters like ion engines and plasma engines for long-term propulsion. These types of engines use electric power to consume a propellant supply which is limited, so some folks think of them as hybrid electric thrusters. Hybrid electrics use a lot of power to rapidly accelerate propellant from an exhaust outlet, causing a very gradual acceleration. Hybrid electrics are much more fuel efficient than rockets. They really stretch their fuel, gradually accelerating through outer space for a long time. When you spend a long time constantly accelerating through outer space, even if you're doing so very gradually, you can reach a very high velocity. Using a hybrid electric engine on your spacecraft is far better than coasting through space. Unfortunately, the thrust these hybrid electrics generate is so low that here on Earth, they cannot even move themselves. Time for a little experiment. NASA performs spaceflight experiments involving helium balloons, so we'll try that too. Let's say you used a huge helium balloon to float the most powerful hybrid electric engine in midair, and then you activated it. It turns out that even on a perfectly calm, windless day, it wouldn't be able to outrun something as slow as a glacier. That's a very poor amount of effective thrust. Come on, this is the 21st century. We can do better than that. What space travel needs is a new and improved electric engine that generates much greater effective thrust. Well, there is a groundbreaking electric space propulsion engine with a much lower mass and enough thrust to move in ways that no hybrid electric can. This insulating material-wrapped frame contains a spaceflight engine which is powered by an advanced thrust technology called stellar electric propulsion. It weighs less than 1 kilogram, and its effective thrust is significantly greater than any of those older designs. We tried that balloon experiment with the new engine design, and here's a video of it in action. Inside the silver gondola beneath the balloon is a working prototype of this new game-changing engine. It works great down here in a lab, but it will also work in outer space, where it would not need a helium balloon to stay aloft. When it is in space, without Earth's atmosphere to slow it, this new engine will be able to maneuver much faster than demonstrated here. Better still, its maximum velocity will be greater than any spacecraft humans have ever made before. The sharp-eyed among you may have noticed the test vehicle making some course changes. It's able to do that because the engine's thrust is electronically vectorable. That means the thrust can be redirected, steered, and the entire vehicle can be reoriented. Here's another cool bit of information. This new engine is more power efficient than any hybrid electric thruster. Some of the hybrid electrics require 100 kilowatts of power to ionize and accelerate their fuel supply. In this demo, the new engine is using less than 1/2 of 1% of that amount of power to generate its thrust. That means not only is the engine itself lower in mass than those old thrusters, the power source you need to make it work is far less massive too. In spaceflight, you want your vehicle to have the smallest mass possible. Saving mass means potentially higher velocities and less time spent traveling through space. One more thing. You may have noticed I haven't mentioned what kind of fuel the new engine requires. Well, unlike hybrid electric engines, this new technology needs absolutely no fuel or propellant. It is purely electrical propulsion. Out in space, it will be run on solar power. Now that is a 21st century propulsion technology. If you're interested in seeing this new space propulsion technology develop further, there are several ways to support the project. For more information, go here. Thank you very much. We appreciate your support.